I'm sorry. Okay. So now that we're recording, what we've got this week, in addition to the hypothesis testing lectures and the quiz that I will get up as soon as we get done today, is this journal club assignment using a paper. So we're all going to review this you et al. Paper that was published in 2014. And the reason that we are going to all look at this paper is that it actually takes a pretty in-depth look into biodegradation of compost. So it's along the same lines as the research that we're going to do. This was actually one of the papers that I used to write the grant proposal for this project. And so we're all going to read this paper, and while you guys are reading it, you can download this journal club assignment. It's in a Word document, so you can edit it easily, and you can fill in the questions associated with this assignment. And so let me show it to you really quickly because it changed screens on me. So it looks, it's got some questions associated with it. So, and they're split up into different sections. So overall, what is the voice of the paper and the writing style? What does the author and title section look like? What elements are in the introduction, etc. And so this assignment is worth 35 points. I think that's right. I think 35 points. So let me look real quick. So this is the first of kind of our bigger assignments, 30 points. So that is one of the assignments that is due this week, or the activities that's due this week. And then we are also, let me switch back over to student view. Today we are going to talk through developing hypotheses associated with the actual research project for this class. So your last assignment is going to be, let me get to it. This discussion assignment. And so it is where you guys basically take a Word document. You're going to write in your hypothesis or your pairs of hypotheses. You're going to identify the independent, deep, and dependent variables, as well as the experimental unit in each of those hypotheses. Save it as a PDF and re-upload it here for a quick 10 points. And so this assignment should be pretty easy because we're going to do most of the work in discussion today. All right, so just to reiterate, what we have due on Friday by end of day is the hypothesis testing quiz, which I will get up as soon as this is over. I apologize, it wasn't up yet. The journal club assignment, which is going to take you some time, please start early. And the hypothesis testing or the hypothesis development assignment that is associated with today's discussion. So all three of those things are due this Friday by end of day. Any questions? All right, fantastic. Okay, guys, well, we are going to continue our discussion about compost. So 2 weeks ago, we talked about kind of the background of how this compost project got started, some of the regulation that was around it. And today we are going to jump into how we set the project up and the resources that we have available. And then we're going to spend some time individually, then in breakout rooms, then together as a class, talking about what components we're interested in determining as part of this research process. So you guys are going to get to help us actually develop the hypotheses and the objectives for this project. So I want to share with you the do this real quick, the PowerPoint that we've kind of been working on or working through. So let me share that with you. All right, so this is the PowerPoint that we started with 2 weeks ago. We originally talked about kind of the problem that was associated with this composting process. today we are going to focus on the literature review portion, which happens to coincide with the journal club assignment, and then developing hypotheses. And so we're still in the very early stages of this scientific method process. So, just as a review, this timeline is the process of the scientific method. So, we start clear over here with a problem or a question, and we end clear over here on the right side with a scientific publication. And so, we're walking this out every step of the way. And so, today we're talking about the literature review and the hypothesis development. So, let me just buzz through some of these slides. We've already been through the background of this, why we decided to take this to the research level, because we were experiencing some major issues in the state. So as far as getting rid of livestock carcasses and offal or butcher's waste. And we ended doing a quick activity where we had each person kind of work through some thoughts and questions that this presentation stimulated. So what we're going to concentrate on today is the resources that are available around this research project. So the research project itself is very big. It's multiple years, but we have some leeway to kind of shape our project for this class to the interests of the class. And so it's my intention today to kind of share with you the resources that are available. Okay, with keeping in mind that these potentially will turn into and help inform the materials and methods section of our papers. And so it may help to have a piece of paper or another document going as we're kind of going through this, so that you can list out the resources that are available, because I'm going to present them in several different slides. And so it may help you to have all of that on one piece of paper as we move into the activity portion of today. All right, so without further ado, let's get into the resources that are available for our 490 research project this semester. First and foremost, we have a site where composting is taking place. So this site is roughly 80 feet in length by 12 feet in width. It was constructed with a base or a foundation of base rock. So that's like big gravel that you can actually create a gravel pad, and then you can wet it down and it locks in almost like cement. So it's not exactly like cement, but it definitely makes it very hard. We use it for roads around the farm, all of that good stuff. And so with that site, or with that 80 by 12 foot site, we actually created a 4 different bays that were constructed with concrete blocks. And these concrete blocks are huge and they are heavy. They're about 3,000 pounds a piece. And so we also located this site 200 or more feet away from what we call hydrologically sensitive areas. So it's away from pumps, it's away from wellheads, it's away from seepage ponds, it's away from vernal pools, anywhere that water that there's direct access to water that could really lead to contamination. Because keep in mind, we're dealing with dead animals, right? Or some form of dead animals. And so with that is always the chance of having some sort of pathologic event. And so we want to make sure that that's not getting into the water supply. All right, so that was a big reason why we put in the compacted base rock foundation, and we're away from major hydrologically sensitive areas. And so this figure here is just a satellite view of the university farm. So just to orient you with where we're at, this big building right here is the pavilion. Here's the pavilion parking lot. And this is the main road into the farm. So the location of the composting site is actually going to be back over here in what we call the old pit area. And so the railroad tracks are the property border to the east, and the compost site sits down here just on the other side of a big oak tree. And so we constructed this um, compost facility a little over 2 years ago, so in 2019. And this is what it looked like at the very beginning. So this was taken right after it got constructed. It looks very similar now. But we have four 12-foot by 12-foot bays here. So each compartment has a very specific purpose. And so um, each compartment in this study is really designated for a specific type of composting process. So bay number 1, which is over here on the north side, and bay number 4 over here on the south side, each have 3 levels of blocks. So that's how we help distinguish the research site. And these bays are specifically set up for livestock mortality. So for animals that die on the farm or are euthanized on the farm, we will research the composting method in one of these 2 bays, either bay number 1 or bay number 4. The other 2 bays in the center that only have 2 block or concrete blocks high, these are designated for offal or butcher's waste. And so it's important to make sure that you've got an understanding of this, because the 2 bays that we're going to work the most with in this class are going to be bay 2 and bay 3. So we really aren't going to spend a lot of time with composting livestock carcasses. And the reason for that is because we can't depend on things to die at a certain time at the farm. And so it doesn't make a really good structured research project. However, offal coming from the meat slab is very dependable. So Hayden and his crew, they kill or go through the slaughter process about once a week. And so they have a really dependable source of offal. So that's why, for the sake of research and consistency, we're going to limit our research to offal and butcher's waste that are going to be in bays 2 and 3. All right, so just to give you an idea of what the base layer of these composting mounds are, is we've got underneath this material, we've got the base rock. And then we've got a combination of either rice straw or old kind of moldy oat hay. And then we'll put a loader bucket full of old silage on top of it. And so this creates about 24 inches of that foundational or base layer. And so other research has shown using pine chips or using wood chips works, using other sources of straw work, etc. And so what we had available and what is really available in this area is rice straw, some oat hay, and then we have quite a bit of silage at the farm. And so that is what that base layer will look like. And then the next step is then to layer in the what we call the protein content or the nitrogen component of the compost. And that's so that's the animal or the offal in this case. And so for our purposes, we're dealing with offal. And so it will be placed on top of that base layer, which is 18 to 24 inches. And then we will layer on top of that some more carbon material. So, or a carbon nitrogen mix. So that could be hay, silage, manure from the barns, sawdust, etc. And so that is kind of the basics of the compost mounds that we have been utilizing. And in our situation, our bays are big enough and tall enough that we actually have the potential to layer um, material. So we can actually incorporate more off-fall material into the individual compost mound. So what we have done is we've got in bays 2 and bay 3 of the compost facility, we've got our base layer, which is that oat hay and silage. We've got one layer of offal from the meat slab. We covered it up and waited a week, or we covered it up with some silage, manure, barn cleaning mix. Waited a week, and then we came back and added a second layer of offal on top of that. And we covered it up with the manure silage mix as well. And so our to look at it in kind of a tabular format, this is really kind of a summary of what we have out there and going right now. So we've got 2 bays of offal or butcher's waste from the Chico State Meat Slab. And we took it a step further, and the Meat Slab was gracious enough to help us with the research. And so they actually sorted material from the Meat Slab into 2 major components or potentially treatment. So we've got bone-in material, which consists of tissue with bone fragments, muscle, fat, and trim. And then we've got material that is what we're calling bone-out material, which is digestive tracts mainly. And so again, we took both of these materials, and we kept the bone-in material in bay number 2 and the bone-out material in bay number 3. And the compost mound was prepared in this order. So first there was the base with rice straw or oat hay and corn silage waste. Then there was a layer of bone-in or bone-out material. The next layer was the manure and bedding from the barns. Layer 3 was more bone-in or bone-out material. And layer 4 was the manure and bedding from the barns. All right, so this is, oh, sorry, I probably should have warned you guys. There's going to be some of these kind of crazy pictures on here. So just please be prepared for them. I'm sorry, I should have said something ahead of time. But this is just an image of the bone out material. So these are digestive tracts from cattle, sheep, and hogs out of the meat slab. And so when that material comes off of the kill floor, it goes into these big 55-gallon-ish drum things. And then it goes into a cooler in the back part of the meat slab. And usually this stuff would be picked up by rendering once a week, very expensive, like $95 to $100 or $95 to $100, $120 a pickup. And over a year's time, that could really create a major cost for these small meat slabs. So that's something that we talked about 2 weeks ago in this class. And so this is what the material looks like. And so what we ended up doing, and hopefully my videos will play, is we loaded that into the bucket of the loader. And then we added that material to that base layer of oat hay, rice straw, and silage. And that's Travis Hefner from the beef unit, who is carefully placing the digestive tracts in there. So we don't want this stuff sloshing around. We want to be as careful as possible. So that is layer 1. And that is the bone out material. So again, it's all digestive tracts. And we know it's digestive tracts because we can see small intestine in here. We've got rumen right here. We've got some liver and stuff over here. So digestive tracts. And then he ended up running back to the meat slab and grabbing another bucket load of tracts. And so this became all layer number 1. And the next step was to add this mixture of soil of manure, hay, silage, etc. to the top of these piles. And so we covered them really good. And then we went back through and took shovels and covered every little aspect of it because we want to make sure that the odor is not too bad and that it doesn't really isn't easily accessible to predators and stuff. And yeah, we've got some big rock in there. So that's actually a huge piece of cobblestone right there that will be sorted out or sifted out eventually. All right, so that was the bone out material, so digestive tracts. Let's look at the bone in material and how those mounds were prepared. So this is an image of Hayden with kind of the bone in material off of the kill floor. And you can see we've got an animal skull here. We've got some bones, we've got rib casings. And then we also have these, the red muscle trim portion of material that is being fabricated off of the carcass. So just to give you guys some background, I know not everybody is an animal scientist in here. When we slaughter an animal, the kill floor process of that is to pull out the digestive tracts, to split the carcass, and then put it in the cooler for anywhere from 48 hours clear up to sometimes 3 weeks if we like long aging. And so once those carcass comes out of the cooler at whatever time point it is, it'll then be broken down into wholesale cuts and then into retail cuts like steaks. And so as that breaking down process occurs, there's a whole bunch of trim and fat material and bone that comes off the carcass that isn't associated with that final retail product. And so this trim is also going to be a part of the bone-in material here. And so we'll look at adding the bone-in material to, sorry, this is a little bit fuzzy. I was doing this video, not Ryan. And so we added the first of 2 bucket loads to the bone-in material after we prepped the bay with straw and silage. And then we covered it up with that same kind of manure silage mix that went on top of bay 2 as well. And so now we've got bay 2 is our bone in pile and bay 3 is our bone out pile. And we went back the following week and we added another layer of each respective treatment to each respective bay. So we went back in a week later and added bone in material to bay 2 and bone out material to bay 3. All right, sorry, was there a question?
I have a question.
Yeah.
I noticed that a lot of the material that you use to cover are materials that have really high C to N ratios.
Mm-hmm.
Is there a reason why you didn't pick a material that would help break down quicker?
Great question. So we are, there's lots of different ways that we can help break those carcasses down quicker. Our goal for this project is to keep it as close to possible to what producers will have access to. So producers have access to old moldy hay. They have access to rice straw in our neck of the woods because we grow a lot of rice, and they have access usually to kind of a manure soil mix. And so we could have started adding like lye and some of the other bacteria, or using a different type of stock material to help it get to break down quicker. But we wanted it to be as close to as close as possible to what cattle, sheep, and hog producers would have on hand. So they aren't having to purchase a bunch of extra material. That's a great question, Chloe. Did that answer your question?
Yes, thank you so much.
You're welcome. All right. So, as far as the data collection piece of this, we've got a lot of things that we can do and a lot of things that we are doing. And so I'm just going to step us through what we have available. And I want you guys to kind of start thinking about the information that you would be interested in collecting. And so this is one of our first tools. So in the back of each one of these bays, bay 2 and bay 3, we have a stream gauge. And so this is a metal gauge that has basically height in feet. And so we can tell how high the pile height actually is and if it's changing over time. And so that is one piece of information that we could look at. We also are taking temperature on a pretty regular basis, and I'll go through what a regular basis looks like a little bit later. We're also taking a moisture reading. And that's my nephew, Henry. He was helping me with research one day. But this moisture meter is just kind of a bare bones moisture meter. So we calibrate it, and it will tell us on a scale of 1 to 10, 1 being super dry, 10 being super wet, what the moisture is like. And so this has been good because it allows us to really see where we need to add moisture to which piles, etc. And then kind of the last big piece of um, data that we're going to be collecting is we're going to be taking compost samples at the end of the curing process for bay 2 and bay 3. And we'll send these samples off to a lab and get these results back. And so we're going to look at or have the ability to look at everything from pH, total nitrogen, NP and K, calcium, sodium, boron, zinc, iron, copper, organic matter, which is really important, and moisture content, which is, I'm not super concerned with moisture content by the time it gets to the lab. So we're going to do a better job with moisture content with the previous moisture meter. All right, so that is kind of the mortality composting side of it. The last thing that I want to mention that we have access to is the dairy unit does non-mortality composting. So they clean, and if anybody here is here from the dairy, you guys can help me out here, but they clean the slabs and off every day. And because the cows are coming up and they're out of the pastures and they're eating their grain before they go in to get milked and all that good stuff. And so they generate a lot of manure waste as well. So the dairy regularly composts a couple times a year. And so they have what I'm going to call non-mortality compost that they've graciously let us sample as well and send off to the lab. And so we have, we can do the same analysis as we can with our mortality composting. All right, so with that, I want to move into our activity, okay? So what we're going to do is, got about 15 minutes left. This is perfect. Okay. We're going to take 3 minutes right now, and I'm just going to give you guys some quiet time to write some stuff down. All right. So based on what was just presented, write down what you're curious about. What do you want to know? Okay. You know, kind of the resources that are available, you know, the data that we have the ability to collect, etc. And then at the end of 3 minutes, I'm going to push you guys to breakout rooms, and we're going to share in the group for about 5 to 7 minutes what you guys are interested in. All right. And then we're going to come back together, and as time allows, we'll share. But This is really leading us into that last assignment that I mentioned at the beginning of class, the hypothesis assignment. And so this assignment is due but Friday by end of day through that Blackboard submission. And so you guys are going to write out 2 to 4 sets of hypotheses. And if you don't know what that means, watch the lecture first. Okay. And then I stepped through kind of what an example hypothesis looks like. So, for example, if we were doing a cattle growth study using 2 different rations, we're going to use brewer's grain and silage. My null hypothesis, or my HO, would state there is no difference in total weight gain, average daily gain, or feed efficiency of beef steers fed either brewer's grain or silage rations. Okay, my alternative hypothesis would be similar, but with one major difference. There will be a difference between either total weight gain, average daily gain, or feed efficiency between beef steers fed either brewer's grain or silage rations. So verbiage is very important when it comes to hypotheses. The other thing that dictates a good hypothesis is that it identifies the independent variable, the dependent variable, and the experimental unit. And I'm starting to train you guys with these essential pieces of research because the objectives that we actually follow through on, the actionable item, that is going to appear in our paper. And so it's a very close relationship between a hypothesis and an objective. And so today we're starting with hypotheses. And so in these examples with the cattle growth study, the independent variable is highlighted in red. So you'll need to distinguish that independent variable in your own hypotheses as well. And the dependent variable is designated in yellow. And finally, the experimental unit is designated in, I guess we'll call that blue. All right, so this is all part of that final assignment that you guys will turn in on Friday, but I want to give us some time to work on it today. All right, so let's take 3 minutes. I'm going to start my timer and you guys just write down some things that you're interested in. All right. So I'll let you know when we've got 1 minute left. All right, about a minute left, guys. All right, let's go ahead and bring those thoughts to fruition, get them written down. I am going to open all the breakout rooms right now, and they're just random. So if you guys will head that way, we'll come back in about 6 or 7 minutes.
Time,
Cool.
or I guess
Yeah.
decrease the time,
Awesome.
increase the rate. There you go.
Yeah, temperature is a big deal from a regulation standpoint. So we, in order to have cured compost, we have to actually have it at least 131 degrees Fahrenheit for like 15 days.
Wow.
Yeah. Yeah. It's crazy.
So there is like a minimum, but there's not a maximum.
Right.
Is that
Yeah.
when it comes to? Okay.
Yeah. I mean, I have seen maximum happen actually out at the farm is when it catches on fire.
Yeah, I guess that makes sense.
So, and then it will burn for a long, long time.
So then how do we keep a regulated temperature then?
Oh, great question. So if it's heating up and getting really, really hot, how do you cool it down?
I would think, I mean, I'm not 100% sure at all, but I mean, I would think fans or something, or I don't know.
Water.
Oh, okay.
Yeah. We can add some moisture into it.
Makes sense.
Yep. Awesome. Other thoughts?
I was curious about like the digestive system that they're using, or like, you know, the bone in versus no bone, like
Yeah.
the intestines and all that. Like does the bone versus no bone decompose faster than the other one? That was one of our group's questions. And then also, like, we were curious if or how does just putting that in the layer, how does that even help decompose them?
Oh, yeah. Okay, cool.
Why, or how do they come up with these layers? I just was so interested in.
Yeah, I have no idea how they came up with it other than people, it really started with poultry, I think, because they bin compost poultry in other states. Like Arkansas is a big poultry state. And so as birds die, they actually will put birds in these like 4 foot by 4 foot metal containers, and then they'll put a layer on, and then they'll put a layer of carbon material, and then they'll put another layer of birds and another layer of carbon material. And so that may be where this method actually came from. So yeah, but great. I love your bone in, bone out question. I think that's a big one. Yeah. Sweet. Other questions?
So I thought this whole concept was quite interesting, and I have about 1.5 million questions, I'm not gonna lie.
Awesome.
But I would be really curious to know if the compost was applied to several different plants, how the harvest or the product outcome would affect using that specific compost versus other composts. Additionally, if there was any difference between species. So if you use like swine compost, strictly swine, versus cow versus sheep versus goat, if any of that affected the harvest's outcome. I'd be really curious to know that. Yeah, I thought that was quite a fascinating concept.
Yeah, I think that's a great question. We don't unfortunately don't have the capacity to do this in our class because we're only a semester long, but those are really, really good questions. And so we can kind of get to that a little bit eventually, not necessarily in this class, with the actual carcass versus the offal. So when the compost is technically cured, we could do a lab analysis and see if it's any different. So that might give us some of that information without having to go to the field and do it that way. So those are great questions. Other questions you guys had, or thoughts you had, like some things that you want to investigate?
I don't know if this would be a good question off, but I was just thinking also just like public opinion
Mm.
for this composting method. So that's
Yeah.
just something I was maybe thinking about, but I'm not sure how to like turn that into a hypothesis or anything.
Cool. Yeah. So the public is a really big part of this process. And that was one of the hardest things that
Okay.
we had to address when we got permits. And so we're permitted through Cal Recycle and through Butte County and through their public health office. And the biggest thing that the inspector is worried about is complaints from neighbors about odor. And so that's one aspect of it. So, but as far as like, the general public's perception of compost, um, it's my experience has been a little bit interesting because people first go, "Ooh, you're composting dead animals," and then they're like, "Oh, that's pretty holistic and kind of natural." And so it's really kind of been interesting to hear some of the public's feedback on it. But we also don't have it passed yet, so it'll be really interested to hear the litigator's perspective on that.
Yeah, definitely. Thank you.
You bet. Great thoughts and questions, guys. I could do this all day long, but I'm sure you guys need to get going. You're more than welcome to hang out and go through this another time if you want, because we're going to start the next section at 3. But yeah, just next week, we're going to dive even deeper into this. I'm hoping that the journal club this week will actually give you some more insight into some of the things we're concerned about with compost. And then next week, we're going to develop objectives and we're going to roll. So that is what is going on. So thank you guys so much. And we'll plan on seeing you next week.
Thank you.
You're welcome. Thank you.